Look at Oracle installation followed by an ASM configuration. The machine the server on which we are trying to implement this is a CentOS 4.5 with a kernel version 2.6.9-55, which also indicates an update 5. It is a symmetric multiprocessing kernel. As of now, the disk that we have currently hosts 3 operating systems: Windows, Solaris, and Linux, and these are the partitions. The first partition is for Windows. Second is given to Solaris, one single partition for the entire Solaris install. Then we have an extended partition which is further divided into 3 logical DOS drives, such as Linux partition, which we are given for root, followed by a Linux swap partition close to 2 GB, followed by a small 500 MB partition for /tmp. So here we can confirm that the SDA5 is given for root, SDA7 is given for /tmp. Now this space is not sufficient for us, where we want to first do an Oracle software installation followed by an ASM install. So we will have to further create multiple partitions onto the available disk, where one partition we will create would be around 10 GB each, so that we can implement both software, and then we have enough free raw partitions available for ASM implementation. We will require a reboot of the machine when the partitions are ready for use. So let me first log in and create further new partitions. So I am saying that the disk that I want to work with is /dev/sda. The current disk geometry and the partition table is printed using the P as the command at fdiskprop. And now here is where I want to create additional partitions. So I am saying that I want to do a new partition by saying n, and then the partition type that I want to do is a logical partition, which is nothing but a further partitioning into an extended partition. So once it's L, it's asking me what is the starting and the ending cylinder number. So whatever was the end cylinder number for the previous partition plus 1 is what I want to deal with. So my earlier one was this one, and now I want to create starting from 6923 is okay with me. The partition size, although can be specified as an ending cylinder number, or the size which can be specified in kilobytes or megabytes, here I prefer to choose the size into MB. How much this size would be approximately? 10240M is 10 gigs partition which I want to create for Oracle software installation. Although I am very high on the estimates, but because this partition will also host for our demo databases of flash recovery area, that's why the size I have selected is 10 GB. Because Oracle software will not take more than 4.5 GB in any case. So close to 5 GB should have been sufficient, but on the same partition we also want to put a flash recovery area going ahead. So now you will see that a new partition SDA8 has been added as per your specifications. Now here we want to add few partitions which we don't intend to format going ahead. So we will just create them as partitions, but then we will not format them. So they would be used as raw partitions going ahead. Instead of creating a huge partition, what I am going to do now is I am going to create smaller partitions of 5 GB each. And then we will create, we will assign these raw partitions to the ASM disk groups going ahead. So let's create few more partitions. Let's create 6 partitions of 5 GB each, provided our disk allows them to create. So I'm going to create a logical partition starting at 8169, and the size is close to 5000 M. Should be sufficient enough. Otherwise, to be on the exact 5 GB limit, this is what it translates to. So 5120, let's go with an exact size. So I am creating a 5 GB partition, and such multiple partitions I am going to create now. So how many of them now we have is 8 is where we want to install Oracle software. 9, 10 and 11 are the 5 GB each partition. Let's add few more. Now we have total 4 partitions, each of which is 5 GB. I will add 2 more. So 9, 10, 11, 12, 13 and 14 are 5 GB partition each, and then this is where we want to do the ASM configuration going ahead. So 9 and 10 would form our failover group 1. 11 and 12 will form our failover group 2, and 13 and 14 will form our failover group 3. So we can try a high redundancy related practical. But actual usable space in that case would be just 10 GB. So what we have in each failover group is 5 GB 2 disks. So which should be sufficient for us, and remaining space is an unpartitioned space which we don't want to deal with right away. So is that fine enough? Or let's add all the remaining space as one single partition. So I added last one as the remaining space, which would be a bigger partition going ahead. So to save the changes into the partition table, I am saying W, which saves those changes, synchronizes that one and comes out. But then until I reboot the machine, the new partition table, which contains these many partitions, is not available to the kernel. So to reread that partition at the boot time by the kernel, you will have to reboot the machine. So let's reboot, and we will again, I'm going to pause the video in the meanwhile. Once we are back, we will format one partition, we will keep other partitions as unformatted. So I am pausing that video for a brief moment. So our machine is now up after the partitions were created. Let's verify that the partitions are visible through fdisk-l, name of the device. So I can see pretty much all the partitions. Partition number 8, which reads like /dev/sda/sda8 is where we want to create a file system. And once a file system is created, we want to install Oracle software on top of that mount. So let's create a file system, mk e2fs -j to create a journaling file system on top of partition 8. So the partition is now ready. The only thing we need to do is to mount that partition. Going ahead, that partition would be mounted as /u002. So now instead of making every time that mount command work for me, what I am going to do now is I am going to put an entry into etcfs tab so that every time my machine restarts, the partition pretty much is visible to our Linux machine. So /dev/sda8, this is where I want to mount it, is an ext3 type of a partition. I don't want to play with the partition permissions, so I am going with the defaults value, and then for file system check, which we don't use, I'm going to simply say mount /u002. Now once I see it, I can see a 10 gig partition, close to 10 gig partition, which is /u002. This is where we will intend to install Oracle software. But if I see the partition permissions might not be correct at this moment. So I want to create Oracle user where his group should be DBA. and I want him, the owner of this partition, going ahead. In the meanwhile, while I am doing this thing, I want to initiate a file transfer where I am transferring software from my local machine onto the Linux box, which would be going ahead used for Oracle installation. So this time I am using a GUI window for doing a software transfer, which is a WinSCP tool. And then the partition that I want to transfer this software is to U002. It's available on my local machine. So while this copy is going on, let's go ahead with our user and group creation. So I'm going to add a new group with the name DBA. It says that the group already is present. Now let me also confirm if Oracle user is there. Yeah, so Oracle user is also pretty much present. So let's start with changing the ownership of that mount to Oracle:DBA for U002. So going ahead, that partition is now owned by /U002 is owned by Oracle user. So once the copy is completed, we will go ahead with the installation of Oracle software. So now that the file, software has been copied, let's try extracting that software by saying, if you see the extension is CPIO. So the command to extract this would be CPIO minus IDMV, input sign name of the file. So it looks like we are not a database software, this is something else. This is a clusterware software we have copied. This is of no use for us. We want a database software. So here we are, the software is now available and we are here. So this is the one that we are interested into. So we want to extract this software and then go ahead with the installation. So let me copy this file and let me unzip it from here itself. We are trying to extract that software from the CD under U002. This is where that file is getting created. Instead of doing a copy and then an extract, we are directly doing an extract from the CD-ROM. In the meanwhile, as Oracle user, let's check the ulimit parameters. So the one that is of more interest for us is the number of open files descriptor, which is quite high, 1024, should be okay with us as per the suggested guideline. He says the number of open file descriptor should be set to 65536 and the number of processes at any given point in time should be not less than 16,384. But for our normal database like the one that we are doing, I think this limit is sufficient enough for us. So the software has been extracted. Now the file that I have in place is a CPIO file which I need to extract by saying CPIO minus IDMV. And it's creating a directory after the extraction. So at the end of this one, what I have is a database directory. So let me go into that directory, and this is where our installation or the installer software is available under. We will need a GUI session where we can initiate a GUI. Instead, I start a VNC. I will use a local desktop to start the Xming server on my desktop. Now here we are, the Xming is there. Let me start if I can do a DBCA right away. Sorry, not DBCA, run installer. Software is yet to be installed. So it says the display environment variable is not correctly set. You will have to set it. So instead of doing it, so what it says is set the display to some environment variable. We have that display running onto my local machine, and this is where the display is running. Let me restart a fresh session where it can guess the display value. Here I am onto the fresh window, where while starting up, I am going to say additional settings are required for this one. It's typically for X11. I say enable X11 forwarding, and then localhost :0 is where I want to capture the display. I am logging on to my server. If I start Xclock now, it should pretty much bring the display. So let's go to the installation directory and kick off the run installer. Before I do that, let me set some of the environment variables so that my installer can pick them up easily. And here is the run installer. I am selecting an advanced mode for installation. Pretty much the Oracle base where Oracle inventory would be installed is selected automatically. The group has been picked up. The one that I am going for is a custom install. What name I would like to have to my database Oracle home name. So I'm saying 10gr2 underscore 64 indicates a 10G release to 64-bit, and this is where I want to install Oracle. The settings were only picked up because I set an environment variable outright before I started the run installer. The only additional component I need is ISQL star plus support. Here and there it may complain about certain kernel parameters. So kernel parameters that it is complaining about is about memory segments, past. The only thing that failed was same OPM that has failed, and then SHM max, which has again failed. This is because I believe we put those parameters into place, but then we never restarted the machine. So SHM max is there, and it's complaining about SHM max. Our parameter is pretty much there. Then it is complaining about SEM. So we already have these values set. The only problem is machine was not rebooted after we set this kernel parameter. So there are two options now available to us. Either we do a clean install this time by aborting the current installation and restarting it afresh by rebooting the machine. So I would like to go with that option, because although we set those parameters, but then those parameters are still not into effect until we reboot the machine. So that the server is again up and running, let's try to connect in as Oracle user. And invoke the run installer. This time, however, I forgot to mention the environment variables. It has still warned us about some kernel parameter. It would be read memory and write memory size. So read memory default and write memory default. So the default value should be at least 26 as per given this one, but we don't have a sufficient value set. So I'm going to ignore these parameters and I'm going to go ahead with the installation. It is complaining about a swap, which I am sure is sufficient for our installation. I am saying install just the software. We don't want to install the database. And that's pretty much about the installation. So let it go ahead with the installer. While it goes on and prepares us or does the installation, let's also gear up on the other activity of getting the patch applied to this Oracle home. The software that we are doing an installation is 10.2.0.10, and on top of that we plan to apply a patch. So this is the patch that we want to apply, which is in a zip format. Let's also, while the installer is going on, try to extract it. In this directory. So while the installation is on, the patch is also getting extracted. Meanwhile, installation is still on. Now the CPU intensive activity has started, the copy phase is completed. Now relinking Oracle software once its copy is done is on. This is where the Oracle installation onto Windows and on Unix platform differs. On Windows it's just a copy process. Here it's a copy followed by a relink. In the meanwhile, the software patch that we plan to install is also extracted under /u002/10.2.0.30 patch. So going ahead, we will apply the patch from this location. Let the Oracle software installation get over. So we are currently installing the base release 10.2.0.10. At the end of the patching activity, we want to see it as 10.2.0.30. You get a good sleep when somebody is explaining and light band go gaya. Yes, but then there's a different process. If the patch is causing problem, however, we are applying it only a software patch. The patch is not just applied to a software, it is also applied to the data. Do we have a database? So proper method is to make do a base install, apply a software patch the way we are applying, and then create a database. The database that you get at the end is directly a 10.2.0.30 data. Rather than doing this way, do 10.2.0.10, create a database, apply a software patch, and then upgrade the database to 10.2.0. Anyway, at any given point in time, you can downgrade the data. It's not something which everybody would like. The troublesome activity, but it's possible. If you open the readme file onto 10.2.0 patch, in the same readme file they have described how to revert from this. After patch is installed, it's waiting for Anuradha to execute root.sh. Now installed, and we also ran root.sh as part of the patching activity itself. Here I am, and I'm saying yes, the patch has been applied now. So that was pretty much about the installation of Oracle. So what software version we have now in place is 10.2030. So we will have to create an environment file so that going ahead every now and then you don't have to set the environment manually. So I'm going to put it into the bash profile of Oracle user. pretty much every time you log in, you will get the same environment. So now that the paths are set, now it's time to invoke DBCA, where you can see the ASM configuration. Again, just to give a quick recap of what we have done so far, we had created some partitions. And the partitions that we plan to use for ASM are these 6 partitions. So let's invoke DBCA as normal user, Oracle user, and then go ahead with the ASM configuration. Before we do that, there are certain prerequisite steps that we are not yet done. We just have the partitions which are unformatted, but then some of the steps that we should be doing about changing the permission and binding them to as raw devices with the block devices. The problem with Linux is Linux does not natively support nowadays raw devices. So if I go to /dev and see a listing, some of them starts with B, which indicates a block special device, and some of them starts with a C, which indicates a character special device. Raw devices are character special devices, but then Linux does not natively support raw devices. That is the biggest problem. So you must have a binding of raw devices with the corresponding block devices. So let's bind our raw devices. Our raw devices are named from partition 9, 10, 11, 12, 13 and 14. So we will have to bind those corresponding raw devices with their block devices. So this is because Linux does not natively support a raw device. So you cannot directly work with a raw device until it is bound with a block device. So that binding process happens in the file called as etc. The binding goes into a file etc sysconfig raw devices. Why I need to put these settings into a file is because after every reboot, those services, that binding should be available. And this is how we plan to bind it. We plan to bind /dev/raw, and the partitions that we want to use are from 9, 10, 11, 12, 13, 14. So raw 9, we want to access it as /dev/sda9. And pretty much the same way all others. This should be accessible as /10 and so on. Until you bind them, those raw devices cannot be merely used by ASM. they must be bound with some block devices. The same thing could have been done using a raw command by saying raw partition name and the block device name. But then the problem with this command is the effect is only available for the current session. If my machine reboots, again I have to start typing the same command. Alternative is to put those same commands into etc sysconfig raw devices. Once done, you will have to start the service raw devices. And all of those devices that we put into etc sysconfig raw devices are now available. Now if you go and see the permissions of all these devices, the ownership is with root, isn't it? So we need to change the ownership and also the permissions. Permissions on those devices should be 600 and the ownership should be with Oracle. Now this time I can see that there's a correct permission. But again there's the same problem with these devices also. After you reboot, the ownership will again change back to root. So we should also put a similar command that after every reboot, those settings should be pretty much in place. So I'm putting this command in rc.local because commands in rc.local are executed every time you reboot a machine. So I'm putting the same thing. So every time my machine reboots, the permissions and the ownership is still intact. Now it's time to configure using DBCA the ASM part. So I'm invoking DBCA this time. Here, however, I am saying configure automatic storage management. So it says that there's one service which is required to run on your box, and the name of the service is OCSSD, Oracle Cluster Synchronization Service Daemon, which is not running at this moment. To start this service, execute this command. So go to Oracle Home bin and execute the command local config add. This must be run as root. So let me start that service so that we can have that daemon running. Before I do that, let's check whether we have that service up and running. It must not be. So I don't see that service running, so let me go to the proper path and start it. I'm saying local config and add. At the end of this exercise, you would see OCSSD.bin service up and running. This is a mandatory service for a cluster as well as for ASM. Do you see that service running now? OCSSD.bin, that stands for Oracle Cluster Synchronization Service Daemon. I will go back to our installer and will say yes, now it's up and running. I will again hit the same thing. This time it's not complaining about anything. It says what is the sys password that you want to have. We will keep the same generic password. What are the ASM parameters if at all you would like to change? So what is the ASM disk group, disk string and ASM power limit? So are there anything that you would like to set? I would like to set ASM disk string, where to find the devices. These are the partitions that we want to use going ahead. If you remember, ASM power limit is the parameter which governs the degree of parallelism used during rebalancing activity. Higher the value, faster would be the rebalancing, but higher also would be the impact on I/O. It says DVCA will now create and start ASM instance. After the ASM instance is started, you can create disk groups to be used for your storage. So now it will start the ASM instance. Now once I am here, it allows me to create disk groups. So what type of a redundancy you want, what name you want. Since we have created 6 disks, which are automatically figured out. Why it could find it out? Because ASM disk string was set to where I want to have those partitions, and automatically they were all located. So I am going to create a disk group which says high DG. That high DG is for high redundancy disk group, and I am going to select the redundancy as high. I want all of these disks to be part of, and then what is the failover group to which they belong. So I call this as FG1. My 9 should be under FG1. My 10 should be under FG1. My 11 and 12 should be under failover group 2. And my 13 and 14 should belong to failover group 3. If you don't mention, all of them will go into one failover group, assuming it is an external redundancy. So I have selected all of them. And the name of the disk group, as I said, is high DG. Let's make it more sensible by putting a correct name, high DG. So, given a name which makes sense now, high DG for a disk group which supports high degree of redundancy, allowing 3 failover groups. I type something which is still not coming up. Now it makes more sense. So high disk group. A disk group which has a high redundancy. So it's not allowing me to do. It's taking some time. In the meanwhile, I go back to where we were in the roots window to see if there is any IO weight. I hit OK. The ASM disk group creation is in progress. So all these disks are added, and at the end what we have, is a high DG which is in a mounted state. But how much is the usable space? Usable space is 2 disks of 5 GB each, approximately. It makes it this one, because all other disks are for redundancy only. Once I am done, the disks are already mounted, I am good to do a finish. So my ASM configuration is over. Meanwhile, while it goes off from our screen, let's log into Oracle session to see if ASM instance is up and running. Now, here we are. If I do finally it came out now. Is now done. Let's see if we can look at that ASM instance running in the backend. Let me reinitiate a fresh connection. So here we are on the server now. Once that ASM part is done, so now the ASM instance looks like is up and running. We'll have to go and check what all data dictionary views are available and how to find out information from those data dictionary views.